everybody. My name is Logan Bittner. I am a principal software engineer at a company named Apprise. We are an industry-leading document processing company. Me and my team, we're really big fans of Next.js, and we're big fans of the developer experience that it provides. And in particular, the tools it provides to build great user experiences. In my opinion, a great user experience is crucial to any web application. And one of the most important parts, in my opinion, is web performance. Next.js provides us a lot of tools to optimize web performance and kind of hyper-optimize at a page level. So today we're going to talk about how Next.js lets us do that with all the rendering patterns that they provide. So we're going to define performance first. At a very high level, there's two kind of main metrics to look at. The first one is just your loading time, so how long it takes to get stuff on the screen, how long it takes to display the content that your users came for. And the other one would be just the smoothness of the website, so how it feels to interact with items on the page, things like frames per second almost you could think of. We're going to be talking about loading time today, as this is the area where Next.js and the rendering patterns really make a big difference. We're going to break loading time down into 3 different measurements. The first one is how long it takes to display an application shell, or a skeleton state it's called. And this is the state where you can see some elements on the screen, but there's still not everything. There's loading spinners everywhere. If you load a website like YouTube, you'll see this exact pattern all the time. You'll get like little gray boxes with loading spinners everywhere. The second metric is how long it takes to become interactive. So how long it takes for all of your JavaScript to be loaded, and how long it takes for your users to be able to interact with the elements on the page. And the last one is how long it takes to be fully loaded. So how long for all those pesky loading spinners to go away, and for your users to be able to actually view the content they came for. We're going to talk about all 3 of these today, but the most important one, in my opinion, is the first one here. And it's how long it takes to see an application shell. This is often called time to first byte, or perceived performance. And the faster you can get anything on the screen, the better. Even if it's not the content that the user came for, just displaying even a gray box will make your website feel a lot faster than it actually might be. And what is a rendering pattern? So in one way or another, all of your assets, your HTML, your JavaScript, CSS, need to be processed and built and eventually served to the browser. There's many different ways this can happen, and each one of these different ways is called a rendering pattern. And there are many different rendering patterns to choose from, which is why I chose this topic today. My goal is to kind of teach you about the different rendering patterns and help you decide which one would make the most sense next time you start an application. So to do that, we're going to follow a story. This is Bob. Bob is a young React developer. He's just getting started, and he wants to build a blog. His first project is writing a blog in React. So his requirements are very simple. He just wants kind of a home page with links out to his articles. He's just going to share this with his friends and colleagues, so he doesn't care a whole lot about SEO right now, search engine optimization. And also, he's not going to be updating his website very often. Maybe he'll update it once a month. He's just getting started. So to get started, the first rendering pattern he goes for is called a single-page application. If you've ever used React, when it first came out, this was the kind of OG rendering pattern. And it's still very applicable today. So with a single-page application, your source code is compiled into 2 main files. There's an index.html file and a bundle.javascript file. This HTML file is basically empty. There's maybe some metadata, but there's no actual content in it. But most importantly, there's a link to a JavaScript file. And this JavaScript file is responsible for your entire application. It's responsible for routing and rendering and interactivity and state management. Everything is kind of encapsulated in this JavaScript file. And this JavaScript file can get quite large, something to keep in mind. So when your user loads a single-page application, they're going to request your website, and the browser will request that HTML file, which will be sent back, and your browser will then kind of render the contents of that file. But at this point, that HTML file contains no content with a single-page application. So your user, even though we've loaded the file that's supposed to be displaying content, they're still just looking at a white screen. Afterwards, that JavaScript file is loaded, it's parsed, it's executed, and only now is your app actually visible to the user. So the perceived performance of a single-page app is typically not great because there's so many steps here that have to happen before we're able to display something to the user. Additionally, these websites, single-page apps, aren't great for SEO. A lot of the times, search engines won't execute JavaScript when they're crawling your website. And this means that the search crawler will just see an empty index.html file. And that doesn't look great for SEO. Another thing that could really impact perceived performance is actually your user's physical distance from your web server. So users that are like physically far away will experience much longer loading times than users that are close to the server. Data needs to travel from one place to the other, and the further that distance, the longer that takes. Luckily, there's a very common solution to this problem called a content delivery network, or a CDN. And a CDN just ensures that your static files are distributed amongst the globe, and when your users request those files, they're always getting the ones that are physically closest to them. So this helps ensure that you have a consistent loading experience for everyone around the globe. Loading files from a CDN it's the same as loading from a web server. It's just now we're loading files from kind of edge servers around the globe. So in general, single-page apps, really easy to get started with. They are CDN friendly. However, they are slow. Their perceived performance is not great. There's so much that has to happen before we can render anything. They're not great for SEO, like we talked about. And one thing I haven't mentioned is if I want to update this website, I need to do this whole rebuild and redeploy process every time. And this can be quite annoying if you're making consistent updates to a website. So in general, a single-page app is good for like a small, getting started kind of website. And it's okay if you don't care about SEO and performance, but anything more than that, I probably wouldn't reach for a single-page app, and there's probably a better and easier option. Cool, so Bob, he's built a single-page app, he's got a simple blog going, and now he has a couple additional requirements. He wants to write his content in a CMS, or a content management system, which is just a nice little interface for managing your content. He also wants to start reaching a larger audience. He wants to share this with more than just his friends. So now he needs to care about SEO. SEO is a great way to reach a larger audience. So this is something we need to care about. And as we know, a single-page app is not great for SEO, so we need to upgrade our rendering pattern. And we're going to upgrade to static site generation, which is the next rendering pattern. So a static site generation, there's still a build step that looks kind of similar to a single-page app. But the main difference now is this HTML file actually contains content. So at build time, your framework that you're using, Next.js in this case, there are many other static frameworks, will fetch the data from your data source and kind of render an initial version of the page in HTML. And we still generate a bundle.javascript file, and it's responsible for everything except that initial render. So the initial render is handled by HTML, and everything after that is handled by this bundle.js file. So the output of a static site generation at build time is typically a single HTML file per page. So if I have 5 pages in my CMS, the output is going to be 5 HTML files. However, if I have 1 million pages in my CMS, the output is 1 million HTML files. And this often leads to long build times. This is a common complaint of statically generated websites is I need to build 1 million HTML files, which obviously can take a while. Another downside of a statically generated website is that I still need to rebuild and redeploy to make updates to my website. And this kind of exaggerates that long build time. If I want to add a blog every day, I'm waiting 15 minutes for this build once a day, which can be quite annoying. However, on the flip side, loading a statically generated website is super fast. So we're loading an HTML file from a CDN, so we're loading it physically close to the user. That HTML file contains content this time. So we're able to get something on the screen after loading just a single file now. We haven't loaded any JavaScript at this point, so the page isn't interactive yet, but that's okay. Usually the user takes a couple seconds to begin actually trying to use your site anyways. After this, the loading process is quite similar. We're loading a JavaScript file. It gets parsed and executed, and now our app is fully loaded and ready to go. So static sites are great for SEO because that HTML file does contain content this time, and the search engine doesn't have to execute any JavaScript to see the contents of the page. So static sites, very fast, snappy initial loads. We're working with static files, so we can support a CDN, and they are great for SEO. However, that long build time can be quite annoying, and I still need to rebuild and redeploy to update this website. So again, it's great for something like a blog or maybe a documentation website that's more static, that's not getting updated super often, and it's great for if you care about SEO. But it's not great for a more data-heavy website, something like a dashboard or a social media website where this wouldn't work. And it's not great if your website scales into the thousands of pages just because of that long build time. Great, so Bob's upgraded to static site generation, and now he's getting tired of those long build times that we talked about. What he wants to happen is when he publishes a new content in his CMS, or a new blog in his CMS, he wants it to go live on his website immediately without having to do that rebuild and redeploy step. And as we know, both rendering patterns we've talked about so far require a rebuild to update content, so we need to upgrade our rendering pattern. And so we decided to upgrade to server-side rendering. And this is where things get a little bit more interesting. So with server-side rendering, there is no traditional build step like the last two. There is still a build step, but we're not generating static files. And instead, we have our Next.js server running that's handling each request on the fly. With each request, we're fetching our data from our data source, or CMS in this case. And we're using that to render a dynamic HTML preview for each request. So this means that your user, when they load this website, they're always seeing the most up-to-date content from your data source, which means I no longer have to rebuild and redeploy to update this site. The rest of the loading process is quite similar. We're loading a JavaScript file. It gets parsed, executed, and now your page is fully loaded and ready to go. So server-side rendered sites are great for SEO. It's one of the big upsides. The search engines will always see the latest content in your HTML file, which is great for SEO. There are some pretty big downsides to server-side rendering, though. So the initial load time is directly dependent on how long it takes for that data to resolve. So while we're fetching data from your CMS or your database or whatever, your user is just staring at a white screen because we don't have any HTML to render. And this can lead to very poor perceived performance with SSR, especially if your database or CMS is under load and it's taking a while to resolve data. Your performance is really going to suffer. Another downside is that since we're working with now fully dynamic HTML files, we can't cache anything, which means there's no CDN support. So your users kind of around the globe are going to experience longer loading times than if we were able to cache these files. So if you think about it, though, most websites aren't fully dynamic. Most websites have a combination of dynamic content and static content, or not most, but a lot of websites. So if you think of a blog homepage, for example, maybe things like the list of blogs and a featured blog are coming from a CMS, coming from a data source. And things like a navigation, a header, a footer are more static. They're kind of hard-coded into your source code. And luckily, there's a new-ish feature in React that actually lets us make this divide between static and dynamic content. And that is called React Server Components. And these are a relatively new concept that are very powerful, and they're kind of changing the way that web applications are designed. So React Server components let us render an initial preview of the page where the static bits, the green bits here, are rendered as just HTML as normal. But the dynamic bits are rendered as holes, they're called. And holes are a place where there is going to be content at one point, but it just is not ready yet. We haven't fetched it. And holes are usually filled with a loading spinner. And again, like an example like YouTube, if you load YouTube, you'll see loading spinners all over the place. This is kind of what they're doing. What's cool about server components is that once that data has been fetched and it's ready to go, it's actually streamed to the client, and those holes are filled in automatically with that content. So at runtime, it looks a little bit like this. It's a little bit complex, but the Next.js server is still processing each request. But now it's rendering the static parts of your page as HTML immediately without waiting for that data source to resolve. And it's sending that back to the user immediately. So your user gets to see that skeleton state very, very quickly without waiting for data to resolve. The rest of the loading process on the client is quite similar. We're loading a JavaScript file. Now you get an application preview. Once that JavaScript file is executed, your app is fully loaded, but we still have those holes. What Next.js is going to do now is it's going to kick off kind of an asynchronous process, and it's going to fetch that data from your data source, your API or your CMS or whatever. And once that data is ready and cleaned up and ready to display, it'll be streamed to the client, and those holes will be filled in for you automatically. So this lets us get a skeleton state very, very quickly to the user because we don't have to wait for any data to be fetched. But we're still able to support this concept of having like real-time, up-to-date content. So server-side rendering, both of these patterns with and without server components are great for more dynamic, personalized pages, better for like something like a dashboard or a social media website. They're both good for SEO because the search engines will always see the content in that HTML file. Even with server components, the way they engineered React Server components forces the search engine to wait for that stream data to be resolved, which means it's still good for SEO. However, if you don't use server components, your perceived performance is really going to suffer. And neither of these patterns support a CDN, which is a very big downside for a lot of companies. Great, so Bob's upgraded to SSR, server-side rendering, and now his users are yelling at him again. He's dropped CDN support, and his website's feeling sluggish for people kind of far away from his server. So he's in a bit of a pickle. He needs to support a CDN to make all of his users happy, but he also wants his website to update without having to rebuild. And we have not talked about a rendering pattern that supports both of these things yet. So we need to upgrade, and we're going to talk about the next rendering pattern, which is called incremental static regeneration. So ISR is kind of a mix of server-side rendering and static site generation. So we do have a traditional build step where we're generating an HTML file per page in our CMS, and each HTML file does contain content. But what's cool now is at runtime, we have a Next.js server running that's rebuilding these assets on a given interval. So let's say every 15 minutes is configurable, but let's say every 15 minutes, Next.js is going to rebuild these files and re-push them to your CMS, which is great for a website like a blog. With a blog, it's okay if there's a 15-minute lag between you publishing it in your CMS and it going live. Your users won't notice that 15-minute lag, and that's totally okay. But for something like a social media website, for example, this probably wouldn't work because it's not acceptable to have a 15-minute lag to see up-to-date content. So loading a website that uses ISR is very similar to a static site. So we're just loading static files from a CDN, which is very, very fast. Where that HTML file contains content, so we're able to display a non-interactive preview of the app very quickly. And then we're still loading a JavaScript file that makes our page eventually interactive and fully loaded. The big difference now here is just this Next.js server, which is, again, rebuilding these assets every 15 minutes or whatever interval you choose. One thing I want to mention is that with incremental static regeneration, you cannot use those fancy server components we just talked about. So you cannot do that concept of rendering with holes and streaming content. With ISR, we're playing with just static files. So if you did want to have something a little bit more dynamic on your site, this probably isn't the rendering pattern for you. So ISR is great. We're working with static files, can be served from a CDN. We don't have to rebuild to update our content because that happens for us on an interval. The only big downside of ISR is it doesn't support any real-time data or React Server components. So it's great for something, again, like a blog or a documentation website or even a marketing website that doesn't need to be updated in real time, but not great for a more heavily dynamic website that you need real-time or like user-personalized data. And ISR is actually what prize.com, the company I work for, this is what we use for our marketing website. Great, so Bob's upgraded to ISR. His users are happy. He has a CDN. He doesn't have to update his or rebuild his website to update it. But now he wants to get a little bit fancy. So he wants to add a way for his users to log in, and he wants a way for his users to like blogs and get recommendations for blogs based on what they've viewed and liked. So now we have an actual real-time data requirement. Things like likes and recommendations are user-specific, and it's not acceptable to have that 15-minute lag. So again, we're in a little bit of a situation now where we need to support a CDN, and we need to support real-time data, and we haven't talked about a pattern that supports this. But luckily, the Next.js team has been working on a new experimental rendering pattern that I'm very excited about called partial pre-rendering. This is not ready for production yet, but it's hopefully going to be soon, and I'm very, very excited about this. So partial pre-rendering lets us come back to having this divide between fully dynamic and static parts of our website. The static parts of the website now can leverage incremental static regeneration. So things like a blog list and a feature blog, they can be updated on an interval every 15 minutes. And things that are dynamic can leverage server components. So they can be streamed in using those React Server components we talked about. What's really cool now, though, is that the static parts can actually be served from a CDN, which means that we're able to get a skeleton of the app with most of our content on the screen very, very quickly. And we're able to support true real-time user-personalized content. So now when your user loads this website using partial pre-rendering, they immediately see an application shell that's served from a CDN. And again, this shell is updated on an interval every 15 minutes. And the dynamic parts are streamed in using React Server components. So this meets all of our requirements we talked about today. It's good for SEO. It allows us to update our website without having to rebuild. And we can support a CDN. And this is the only pattern that supports all of these things. So partial pre-rendering is on its way to becoming the default rendering pattern of Next.js, and I hope the web. I really think this is really powerful. One really cool thing, though, about Next.js is that you can actually choose a rendering pattern per page. So if you have a home page that's more static, you can leverage something like static site generation, something a little bit more simple. And then for the more complex parts of your website, like a dashboard or something, you could leverage server-side rendering or partial pre-rendering or whatever one makes the most sense. And I think this is extremely powerful, and this really helps you hyper-optimize your website at a page level, which really helps you build great user experiences. So that's all I have today. Thank you all for listening. I'm really excited to be here.